Hello everyone, this is Heating Curves Made Simple with Ms. Rodriguez, and today we're going over some heating curve example problems. So for our first problem, how much energy is required to melt 50 grams of ice into liquid water? So here we have our formula, Q equals mc delta T, and for this problem we know that we have 50 grams of ice and we're turning it into liquid water. So if we're going from ice to water and there's no temperatures listed, then we know we're going through the heat of fusion. And the number for heat of fusion is 333 joules per gram. Now our formula for specific heat is Q equals mc delta T. But when we're not given a temperature, then it turns into Q equals m times delta H. And to determine between fusion or vaporization, we just have to look at what state of matter it's changing into. So we're going from ice to water. That means we're doing heat of fusion. So to solve this problem, it's Q equals M, which is 50, times delta H. And in this case, we're using heat of fusion, so times 333. And we get our answer, which is 16,650 joules. For our second example, which is very similar, how much energy is required to turn 50 grams of liquid water into steam? So again, we get a mass but no temperatures, so we know that it has to either be heat of fusion or heat of vaporization. In this case, we're going from water to steam, so liquid to gas. So that is heat of vaporization, which is equal to 2,230 joules per gram. We're using the same formula, so Q equals M times delta H, but now we're using vaporization instead of fusion. So to answer this problem, it'll be Q equals M, in this case M is still 50, times our delta H, which is our heat of vaporization, which is 2230. We plug that into our calculator, and we get our answer, which is 111,500 joules. Now, what do we do if we're given both masses and temperatures? So looking at our next example problem, we have 10 grams of ice, and it starts at negative 20 degrees Celsius and turns into steam at 120 degrees Celsius. So we're starting all the way down here, so below zero at negative 20, and we want to end up all the way up here above 100 at 120. Every time that line shifts, you have to plug in a new equation, so that determines a new segment. So for this one, we're going to have 5 different segments. And for each of the segments, we use the same formula. So Q equals mc delta T. Starting with our first segment, we're going from negative 20 to 0. For our next segment, we're going through the heat of fusion. This side 0, this side is still 0. So we're going from 0 to 100. Then we go through the heat of vaporization. And for our last segment, so here's 100, this part is still 100. So our last section, we're going from 100 to 120. And now let's plug in all of our sections into the same formula. So Q equals mc delta T, starting with the first section. So for the first section, our M is 10 grams, and it's going to stay 10 grams the entire time. We're at solid, so solid means ice. The C of ice is 2.01 times the change in temperature. So we're going from negative 20 to 0, so the temperature changed 20 degrees. We plug that into our calculator and we get our answer, which is 402 joules. And that's how we get the Q for our first section. Now the Q for our second section. So Q equals still 10, because again, our mass doesn't change. We're going through the heat of fusion, so that's times 333, and we get our answer, which is 3,330 joules. And that's our Q for section 2. So now we're in section 3, so Q3, MC delta T, M is still 10, but now we're at liquid water, so C of water is 4.18 times the change in temperature. So we're going from 0 to 100, so it changes 100 degrees. We plug that into our calculator, and we get 4,180 joules. And that's the Q for our third section. Now let's go through our fourth section. So Q4, still the same M's, so 10. Q4 goes through our heat of vaporization, which is 2,230. We plug that in our calculator, and we get 22,300 joules. And now we go through our fifth and last section. So to get Q5, still the same M, so notice that the 10 grams stays the same the entire time, but now we're at gaseous water, which is steam, which has a C of 2.01, times the change in temperature, so we're going from 100 to 120, so it changes 20 degrees. We plug that in our calculator, and we get 402 joules. So to get Q total, we have to add up all of the Q's from all of the different sections. And once you add that up, so you plug it in your calculator, and you get 30,614 joules. And that is your final answer. All right, so that is how you answer a heating curve problem. Thank you so much for your time. Let me know if you have any questions in the comments below. If you found this video helpful, make sure you hit that like button and subscribe so you don't miss any of my future chemistry content. If you happen to be a chemistry teacher and you would like worksheets, labs, or activities that align with the Thermochemistry Unit or any other unit in high school chemistry, I do have a TPT store called Chemistry Made Simple. I hope you have a good day. Bye.